This is a video on limits to infinity. So let's talk about the possibilities, what we could have here, and some strategies. So limits to, and I should say plus or minus infinity. So let's start with the problem. So limit as x goes to infinity. Say I had 4x plus 1 over x squared minus 5. Now, if you plug in infinity, of course, isn't a number, so plugging in something huge to the numerator and something huge to the denominator, well, that's not really helping me out here. So one strategy for figuring out limits to infinity is to multiply the numerator and denominator by 1 over the variable of highest degree. So in that case, I notice the variable of highest degree is x squared here. That means the variable raised to the highest exponent. So I'm going to multiply the numerator and denominator by 1 over x squared. And in doing so, I get, so still dealing with the limit as x goes to infinity of, well, distributing 1 over x squared to the numerator, I'm going to have 4 over x plus 1 over x squared divided by 1, because x squared over x squared is 1, minus 5 over x squared. Now, if I think about plugging in huge values for x, I'm going to have the numerator, the 4 over x will go towards 0. The same with the 1 over x squared. 1 is just 1, and then minus 5 over something huge will go towards 0. So 0 over 1 is just 0. All right, so that limit as x went to infinity for that first problem was 0. Well, let's try a different problem. What if I had this problem, limit as x goes to infinity. Let's do 4 minus 5x squared over 2x squared plus 1. So let's think about the same strategy, multiplying the numerator and denominator by 1 over variable of highest degree. Okay, so this is going to get me the limit as x goes to infinity of 4 over x squared minus 5 over 2 plus 1 over x squared. Now, if I think about plugging in huge values for x, I'm going to get 0 minus 5 over 2 plus 0, or negative 5 halves. Well, doing enough of these problems, you notice a pattern occurs, and that is like some rules develop. Notice that for number 1, the degree of the denominator was greater than the degree of the numerator. So in other words, the denominator in number 1 was degree 2, and the numerator was degree 1. So when the degree of the denominator is greater than that of the numerator, the limit as x goes to positive or negative infinity is going to be 0. But in number 2, the degrees were the same in the numerator and the denominator. So in that case, the limit as x goes to infinity ends up being the leading coefficients over each other. So in front of x squared was negative 5, and in front of x squared in the denominator was 2. So that's why you were left with negative 5 halves. So let's write that down. So again, we're dealing with limits to plus or minus infinity. So rules for limits to plus or minus infinity. So if degree of the denominator is greater than the degree of the numerator, the limit equals 0. And if the degrees are the same, so if the degree numerator equals degree denominator, the limit is equal to the leading coefficient of the numerator over the leading coefficient of the denominator. And one thing to kind of tie back to what you did last year in pre-calc is when we're talking about limits to plus or minus infinity, we're talking about the end behavior of a graph. So we're talking about as x gets huge positively or negatively, are the y values approaching, in this case, a particular number? And if they are, that particular number corresponds to the horizontal asymptote. So for example, if I were to, since the limit of number 2 ended up being negative 5/2, there means as x gets huge, it's approaching this horizontal asymptote of y equals negative 5/2. And in number 1, it would, as x gets huge, it'd be approaching a horizontal asymptote of y equals 0. Well, what about the third scenario? We haven't talked about if the degree of the numerator is greater than the degree of the denominator, then the limit does not exist, because the graphs either, depending on the problem, that graph will either be approaching positive or negative infinity, so that's not a specific number. So we would say the limit does not exist. Okay, so that's a little bit about limits to positive or negative infinity.